Hello and welcome to the Big Questions Made Little. My name's Rocket and today I'm talking all about the neutrinos. But what is a neutrino and how do they work? I'm here to tell you that now, so this is the Big Questions Made Little. There are three types of neutrino, or three flavors. The electron neutrino, the muon neutrino, and the tau neutrino. They're all produced by interactions of the weak atomic force with electrons, muons, or taus, respectively. So an electron neutrino is produced when an electron has a weak nuclear force interaction, and the same for the muons and the muon neutrino, the taus, and the tau neutrinos. They only interact with gravity and the weak nuclear force. So they usually just pass through normal matter undisturbed and undetected, because at the nanoscopic, at the picoscopic level, gravity is very weak, and obviously the weak nuclear force has the word weak in its name. The word neutrino comes from neuter, an abbreviation of neutral, which refers to the fact that it has no charge, and ino, which means small or zero, which refers to its mass. For a very long time we all thought that they didn't actually have a mass. They do, but it is very, very little. The mass of a neutrino depends, but usually it's about 0.12 electron volts divided by the speed of light squared. I'm going to explain a bit about what that unit of measurement means. An electron volt is a unit of energy. It's roughly 1.6 times 10 to the negative 19 joules, which is how we usually measure energy in physics. It's the energy needed, this is the definition, for the charge equivalent to one electron to move across the potential difference of 1 volt. When you do circuits, you will learn that energy in a circuit is the same as the current times the time times the voltage, because current times voltage equals power, which is energy divided by time, and if you times both sides by time, that's fun to see, you get energy equals current times time times voltage. And because current equals charge divided by time, then current times time is charge. So the energy is the charge times the voltage, which is why the charge equivalent to 1 electron times the voltage of 1 volt is 1 electron volt, a unit of energy. When referring to the mass of the elementary particles, because they're so small we can't really measure them in grams or kilograms, we tend to measure them in electron volts divided by the speed of light squared. You all have heard of Einstein's famous equation, E equals mc squared. This means that energy equals mass times the speed of light in a vacuum squared. The speed of light in a vacuum is 299,792,458 meters per second. This squared is a really big number, but you've then got to divide that by just 1 electron volt, which, as I already said, is really tiny. So 1 electron volt divided by speed of light squared is the same as 1.783 times 10 to the minus 33 grams, which is very small. That's very small. That is an insanely small mass. That's how tiny 1 electron volt divided by speed of light squared is. And neutrinos are usually 0.12 of these. All types of neutrinos are roughly the same, to be honest. It's more to do with the way they're produced by interactions with electrons, muons, or taus that tends to change what they're called. The normal difference between things like other leptons, the electrons, muons, or taus, or the different types of quarks I've gone over before, is to do with their mass. But these neutrinos, all have roughly the same mass. It does tend to change a little bit from time to time, but for 95% of the time, neutrinos have this 0.12 electron volts divided by speed of light squared of mass, meaning that there is really no difference between them in general other than the way they're produced. So that's just about all you could really know, or could want to know about the neutrino in a nutshell. Thanks for watching. The reason I wasn't on last week was we were having a little bit of a break, because obviously normally I do only have to do 3 episodes in a go. That's what I did last series. However, for this series I'm doing 6 episodes in a go, but I had to have a break between episode 3 and this episode, episode 4. But next week and the week after, I will be back, finishing off this series all about the elementary particles, and I will be talking about the bosons. That's gonna be an interesting one. Until then, guys, thanks for watching, and girls, thanks for watching. I will see you later. Bye.